Guys, today we're up to chapter 13. Basically, the term is almost over. 13 is the last chapter. A little complicated till you get the hang of it, about linear programming. Let's see. We're going to be doing an example. That Antonio asked me to do, chapter 13, number 6. Let's get there. Let's see. We have radar detectors, two types of models, laser stop and speed buster. Both models use the same electronic components. Linear problem produce the number of speed buses. Okay. Basically, what we're saying is for each unit of the laser, which is L, you're going to make $123 profit. And for each unit of S, you make $134 of profit. So you would think, well, and since they use up the same components, let's make the maximum of this and the minimum of that, because it's more profit. But it takes more work to make the more profitable one, the speed buster. And we have these constraints that for each unit that you make, you have to spend 19 hours of labor, for example. For each unit of S, you have to have 11 hours of labor. So that you know what? Right. So for this third line didn't exist, you would say make again as many as you can of these because it uses up even less resources. But this one here has another constraint. For each unit, you use up 9 of these. For this one, you only use up 6 units of resources. And of course, they all have to be 0. So how do you do this? Well, I'm going to solve this using the free add-on to Excel, which is done by going to, let's start the Excel function. Let's start a spreadsheet. I'm going to search for Solver. That's the name of the load a solver in Excel. And this is the help menu text. This is basically go to File, Options, Add-ins. This is I already added it in, but you see it over here. You say go, and then you click on the add-in. Anyway, if you do that, you would get the solver loaded. So when you go to data, it will show up under here, under solver. Okay, but once you have it, you do the following. First, you want to have the variables defined. And the variables are, make it more space, make more space, make more space. The variables are going to be L and S. And they're going to start out with 0. The actual value will be, the solver will solve for it and give you the optimum, but we need to put a number in to start off the process. Back to the problem. And 123 and 134. So I'm going to go back here. Objective function. Maximize. Sometimes you want to minimize. And again, we're going to solve it by something called linear programming because all these constraints and objective functions are linear functions. No squares, no dividing variables, no sine and cosine. So we have equals 134 times. Now these are going to be the solutions. How many units of L and how many of S you're using. And these are just there to help us visualize it. So it's times C1 plus, got the numbers again, plus 123, 134. 123, 123 plus 134 times C2. Oh, all right, C2. Okay, but right now it's equal to 0. Next, we have the constraints. 19L, 11, 5,000. Get the line just to make it easier. Constraints. $19 times C1. Oh, I left out the equal sign. Equals 19 times C1 plus 11 C2. Up, put up. That'll work. Popped over the thing again. C2. Okay. And subject to a maximum of 5,000. This is the maximum limits. And the next one is 6,945,000. Oh, no, I don't want 5,000. I take it back. The limit is 5,000. Yeah, I made the same mistake. Limit here is 5,000. Next constraint, getting the hang of this, 6,945,000. So it's 6 times C1 plus 9 times C2. Of course, I left that equal sign. Oh, let's try it again. Equals 6 times C1 plus 9 times C2. That should be 0 at this point because these values are initially 0. And this first constraint was 4,500, found in cell C7. Now, there's one more constraint. We want at the end of this whole thing, it might turn out that some negative values are give you a higher profit, but we can't have negative values. If you go back to the constraint, they tell you these have to be 0. So now how do you implement this? How do you solve the problem? Well, you go to Data, Solver. The objective function is found in B4. So click on it. You want to maximize, as opposed to some examples you might want to minimize. The variable cells are found here, C1 and C2. Subject to the constraints, let's add a constraint. The cell reference is, the first is B6. So B6 less than or equal to the number found in C6. Add another constraint. Found over here. Remember this, if you recall, it was 9 C1 and 11 C2. Again, less than or equal, could be a greater in some examples, but we want it less than or equal to. And the constraint is found here. And So we have another 410 to use, but that's just called a slack variable. Okay, so let's see if the answer is right. 0 of those, and what I just say the answer was? 454.54. Maximum, and the profit was, according to the spreadsheet, $60,909.09. 60,909.09. Check answer. Oh my God, I got it right the first time we did this. Okay, component A is a binding constraint on the first component. Is a binding constraint. Remember, we used all 5. Let's go back to this thing here. This is constraint A, and we used all 5,000. This is slack. We have some left over to use, but we can't use it because it would violate the other constraints. But we do have that material left over, and it's 4,500 minus 4,090. Let's try that. Is not a binding constraint. It has slack of 0 by definition. This has 5,000 minus. Oh no, I'm sorry. 4,500 take away 4,500 take away 4,090.90. 4,090.90 equals 409.1. Let's see if that's right. Check answer. That's it. We're done. Whoa. I'm happy it worked out so nicely.